Okay, a second video about the modifications implemented on the Glitter 811H spot welder, and the HELTEC HT-SW02H. I opened the case. It has two small, let me show here, two small self-taping screws in the bottom of the front panel, which I replaced by 3mm screws, Allen screws. They are stainless steel. And now let's open the... first I will show some modifications that are made to the welder. Originally it has only one fan for cooling the power supply Mosfets heatsink. I made this bracket from aluminum and mounted a second fan. The original fan was replaced because it was a high level of sound. It produces let me try to show here the heatsink. It's from, let me zoom in. The heatsink, it's from here, the first fan, aligned with the first fan, down to here. Let me, where is the second fan? And then with two fans, the heatsink is totally receiving air blowing from the fans. The power supply already have two sockets for the fans, and that's an easy upgrade. The voltage here is 24 volts. The fans must be 24 volts. I used a resistor which is orange, black to reduce the fan voltage and reduce the noise that it produces. This is one of the modifications. Another modification was to mount a 60mm fan by 15mm. I used just a minute. Okay, I used four bolts to mount it. This blows fresh, cool air into the case, and here is a air exit. As I live in Brazil, temperatures here in the summer pass 40 degrees Celsius, then it's a good practice to guarantee the good air ventilation. Okay, let me open the front panel. Allen screw, 4mm Allen screw. We put some kind of, okay. There are two sockets that are bolted to the plate, capacitor bus bar. Okay. Perfect. Okay. Here. One. What we have here. The capacitors are negative point here. It is a plate, aluminum plate, and the positive is here. Okay. We have 6 capacitors. They are mounted in series, 2S series, 6 volts, and 3 parallel circuits. Then it is a 2P3S circuit. Here is the positive side of the capacitors, and here is the negative side. The positive side pass through the Mosfets that are here. It is 80 pieces of Mosfets. It is a first plate here, a second plate here, after the Mosfets, and then it goes to the cable. Here are the cable sockets. The original protection circuit was mounted right here with 1, 2, and 3 bolts, and they are parallel to the cable sockets. So I replaced this circuit by 10 TVS diodes. They are mounted on a copper plate. The copper plate has on this side a double 90 degrees angles. This is 0.4 millimeter thickness copper sheet. On this side of the TVS diodes, I have an double 90 degrees again. Let me show here. Okay. It is a first 90 degrees here, and there is a side plate here, and a second 90 degrees with just a small length. Let me try to show here. Okay, we have the first 90 degrees from here to here, and the second 90 degrees is a small length just to bolt to the plate, and this is the parallel to the cables. Now we have another TVS circuit parallel to the Mosfets, and it is mounted on two bolts, the same bolt used to the Mosfets, to the TVS parallel to the diodes, and here is a second bolt here to mount this protection circuit. It is a small 90 degrees strip, copper strip, that is bolted here on the plate, and then the circuit is have a 90 degrees angle here that is soldered after to the 90 degrees angle here and 90 degrees angle here. Okay, here is the thyristor that is used. Let me try to focus here. Okay, here is a 100 nanofarads capacitor. It is soldered to this side of the plate and in series with a 0.1 ohms 3 watt resistor that goes to this side of the circuit. And in total we have 10 TVS diodes on this side, because it is a double layer, and another 10 TVS diodes here. Let me try to show. Okay, here, double-sided TVS diodes. Sorry about the shaking camera. There are two connections to be made. One is this cable that is screwed here, and the other is a small copper strip that are soldered here and came from the it came from here, the Mosfets connection. It is a parallel connection. One point of connection here on the plate, and another connection here on this Mosfet screws. It is just a parallel connection. It is soldered here. Let me try to focus on a SM8S10A. I used a lower voltage TVS diodes to further protect the Mosfets. Here's the same value, SM8S10A. 10A means that the diode opens at around 10 volts, breakpoint voltage, to protect the Mosfets. Okay, another modification. Here we have a voltage regulator that I searching with the thermal camera identify a high temperature, working temperature, and I glued with thermal glue a small heatsink. Okay, let me see if there is any other modifications that I don't think so. So I improved the cooling of the power supply, improved the cooling of the case, changed the protection parallel to the cables, implemented a new protection parallel to the Mosfets, add a heatsink here, which is a hotspot, and the malfunctioning of the spot welder was totally gone. The big problem, as I mentioned in the first video, is a high voltage spike on the Mosfets, and this is now gone. If there is any information that someone needs about these circuits, please feel free to add comments to the video. Just a final note, all these solutions are obtained with friends on the internet that develop these solutions for some time now. I just contacted them, and they were good friends to teach me how to implement these circuits, and I adapted this solution to the HELTEC spot welder with some minor tweaks to fine-tune its working on the equipment.